Hi, I'm Ben Solomon. Today we look at part 2 of how Propulsion Physics Inc. will unfold over the next 3 years. In my previous video blog, Crisis in Physics, I explained why propulsion physics will be successful. There are 2 reasons for this. First, there are major issues in theoretical physics which CERN researchers are now calling new physics, the need for new physics. And I invented an electrical circuit that could change its weight. And very importantly, that the direction of this weight change could be controlled by changing the direction of the electric field. Over the next 3 years, research and development can be categorized as device characterization, product development, new instruments, and production methods. Device characterization is the methodology used in the semicon industry to determine if their chips are working according to their specs. Propulsion Physics Inc. will use this approach to build better, more stable, more powerful circuits until we reach the point where we have a desktop prototype that can carry heavy weights. This leads us to the second part of research and development, that is product development. Product development in this context is essentially taking a prototype device and converting it into a product that the aerospace industry would be interested in purchasing. That means this is an early reach into sales. The third part of research and development is new instruments. Since some of the equipment we will be buying cost between 50 and 100,000 per piece, is it possible to invent or construct new instruments that are significantly cheaper? The reason why we can take this approach is that the equipment we are buying are generic equipment. This raises the question, can we build specific equipment that's much cheaper, maybe not to completely replace the expensive equipment, but to complement them? The fourth and last part of research and development is production methods. That is, how do we adopt best practices such as design for manufacturability and just-in-time to ensure reliable and rapid delivery of these engines. The evolution of the R&D phase from device characterization, new instruments, product development, and production methods shows us that the business will evolve from a purely research and development organization to a production manufacturing site. And this can be classified into 3 phases. R&D phase, which we have talked about, and second is the initial production phase, which is production of gravity modification engines using lab equipment, which should begin sometime in year 3. And finally, the main production phase that is expected to start sometime after year 3, most probably year 4. The 3 phases of the evolution of the business therefore dictates our recruitment, who we recruit and when we recruit. Initially, at starting, there will be 2 of us, me as founder and my colleague, Chief Science Officer Andrew Beckwith. Our roles are to ensure smooth product development with a solid theoretical basis. Early in year 1, we expect to recruit 2 grade 5 physicist engineers and 1 bookkeeper. As one who believes in teamwork, the 5 of us will come together to determine building leases, lab renovation, and equipment purchases. This is the best way to maximize the value of each of our past experiences. The plan calls for an additional 2 grade 5 engineers and physicists to support and extend the research and development accomplished by the four of us in year 1. And finally, sometime in mid-year 3, we expect to bring on board a senior aerospace defense person who will build deeper relationships with the aerospace defense community. We now have a demonstration product. And in concluding, I would like to say that gravity modification engines, GMEs, will be one of the many products we will eventually research and develop and market. These technologies will be related to force fields and new photon technologies.